So hello again. As you know, I'm Eli the Computer Guy over here for Everyman IT. Today's class is going to be on physical network segmentation. So this is how your network is physically divided up when you build it out. Now in the IT world, in the computer world, you know, we always talk about switches, we always talk about routers, we always talk about logical stuff. And too many times people forget to talk about how you physically lay out a network. How do you actually run cables from point A to point B? How do all those connections in your network get spidered out? Who's responsible for what? So that's what this class is going to be on. It's going to be a pretty short, simple class. This is all very simple stuff, but it's very, very important. Like I say, being a technician for a while now, I've seen too many, especially consultants, that don't think about how they're physically laying out the network. So once the network actually gets built out, it's just a complete mess. So this class is the physical network segmentation. We're not going to talk about routers. We're not going to talk about switches. We're not going to talk about configurations. We're going to talk about, you know, things like something called the Demarc Points. These are where authority for systems transfer from one person to another. We're going to talk about MDFs and IDFs. These are very important facilities when you're in your networking scheme. We're going to talk about the demilitarized zone, DMZ, and then kind of wrap it up with what all these things mean. So stay tuned. Let me take a second, set a few things up, and then we'll go into the class on physical network segmentation. Now the first concept that we need to talk about is something called the Demarc point, or a demarc, or demarcation point. Basically, it's normally just called Demarc, and that's D-E-M-A-R-C. So what is the Demarc point? The Demarc point is the actual place where authority or responsibility for the network transfers from one party to the next. So where this comes in the most, where you're going to see this the most, is the demarcation point for your telco, or your telephone company, or for your ISP, your internet service provider. So, you know, everybody intellectually at least understands that the telephone company or your internet service provider is only responsible for the internet connection all the way up until your building. Then once it gets inside of your building, then it's your responsibility to deal with the network. You know, if a tree branch falls on a telephone line, it's your telephone company's responsibility to fix it. If your switch blows up, it's your responsibility. Again, intellectually, everybody understands this. Business owners don't always. They for some reason they think that, like I say, our local telephone company here, Verizon, is somehow responsible for the routers sitting inside, you know, the business owner's building. They just don't get it. But the main thing to understand is what the Demarc is, and that it's a very important concept. So if you, we're going to talk about it. We're going to have a building today, right? So let's say we have a high-rise office building. This will be our demonstration when we talk about all these different subjects today. And it has multiple floors on it. Now, 9 or 10. So the first Demarc point that you're going to deal with, and that you're almost always going to deal with, is, like I say, the telephone company or your ISP Demarc point. So that demarcation point is going to be sitting either slightly outside your building, slightly inside your building, or literally right on the wall of your building. So like here in Baltimore City, we have Verizon as our telephone company. And so if you have Verizon DSL on literally the outside, screwed to the outside of your building, whether you have a house or whether you have a commercial building, is a little gray telephone box. That is Verizon's Demarc point. So basically, Verizon is responsible for data and telephone signal all the way up to that gray box. The nice part is that gray box actually has little tester prongs on it, so you can test to see is it Verizon's problem or is it your problem. So the Demarc for Verizon or for the telephone company is that little gray box. If you can go out to that box and you can get a strong signal, whether it's DSL or telephone, that means any problems you're having with your network has to do with something going on inside the building. If you go to that Demarc point and you don't get any telephone signal or you don't get any DSL signal, then that says that it's Verizon's problem. So it's basically a very simple way of determining whose problem it is. If you go to the demarc point and you get whatever signal you're supposed to be getting, that means it's your problem. If you go to the demarc point and you don't get any signal at all, then it means it's Verizon or Quest or whoever's problem. So that's the main thing with this demarc point. Now, if you're dealing, like I say, with Comcast cable, they normally have big green boxes like sitting somewhere on your yard. So that's the demarc point. This is something now you as a professional technician need to think about, because when Verizon or the telephone company says, we're going to send a technician out, if it is a problem on our side, we will fix it. If it is a problem on your side, we're going to bill you for it. Well, see, you as a professional technician, you can go to that demarc point yourself, you can open it up, and you can test to make sure that you're getting a signal or not. So, like I say, if this is for your company or if this is for your client, you may be able to save the client, $100 or $200 if you yourself go to that demarc point and see if there is a signal or not. Because basically, like I say, the telephone company, Comcast, Quest, whoever, if they go to this demarcation point, they plug in their equipment and they get a good signal, you just got billed for that trip for them to come out there, because it says that their equipment is good. The problem is on your side. So the first thing is the demarcation point for, like I say, internet service providers, telephone companies, etc. This is going to be, like I say, either slightly outside your building. So like I say, with Comcast, they normally have these weird little green boxes that sit in the yard somewhere. It might be there. It might be slightly inside the building. So sometimes with commercial buildings, they'll run the cable inside the building and then have a panel on the wall. That'll be the telephone company's demarc point, or it'll literally be screwed right outside on the building. Like I say, here with Verizon Telephone, they actually screw this gray box straight onto the outside wall of your business or residence. That's their demarc point. So now, once you understand the first demarc point, so you have the telephone company. Now you, either as a consultant or as a business owner, there's another demarc, at least one more demarc point that you're going to have to be dealing with. Now, if we have this office building here, or if we have like a long office park, you most likely are not going to rent out every single floor in this office building. If you go to an office tower here, even the biggest in Baltimore, even the biggest company, they rent out 1 floor, 2 floors, maybe 5 floors, but they don't rent out the entire building. So the next demarc that you have to worry about is, once the authority has been handed over to the building, now the building property management has cabling that is their responsibility. So like I say, if you go to an office building or if you go to an industrial park, the property manager will actually have their own cabling that runs from the telephone or ISP demarc to your offices. So let's say you're renting out the top 2 floors of this building. So what would happen is they have main cables that would then go all the way up to what we'll talk about in a second, the MDF in your building. So this is the second demarc point that you're going to have to deal with. And sometimes these can be a royal pain in the butt, because if you think Verizon's bad, or if you think the telephone company's bad, if something gets messed up with this wiring, in some of these buildings, it can be a complete just nightmare to get the property management to deal with something. So basically, the demarc point between you and the property manager is then where the property manager's cable gets dumped off into your office space. So the main things to remember with demarc points are where, like I say, authority transfers from one party to the next. You have the internet service provider. And then if you're renting out office space in a building, then the building property management also, so basically the internet service provider drops the cable off to the property management. Property management then gives you a cable up to your office space. So the demarc between you and your property management is, like I say, wherever it comes into the office space. Again, ISPs are actually usually pretty good with this. If something happens, I've seen rats eat wiring. There's flooding. There's all kinds of a mess. This line between wherever the connection gets dropped off for the building and how you get it into your office space can be an absolute nightmare. But the demarc between you and your property manager is wherever the line gets dropped off in your room. So no signal at all. That means it's the internet service provider's problem. If you get a service signal to here, but you don't get any signal here, then it's a property manager's problem. Understanding how this works will save you time, energy, and money. I can't tell you how many technicians and how many business owners I've seen scream at the telephone company for a problem that is the property manager's fault. And like I say, most people don't understand how this works, and so the property manager, they don't want to spend any extra money, you know, fixing their own wiring. So they just shrug and go, oh, it's Verizon's fault. And if you don't understand how the demarcs work, you're going to think it's Verizon's fault. You're going to keep screaming at the telephone company, and the telephone company's not going to help you because it's not their problem. So that's how the demarcs work in. Big thing. So now the next network segmentation we need to talk about are MDFs and IDFs. So this is MDF and IDF. This is called a main distribution facility and an intermediary distribution facility. These can also be called frames. When I was doing research for this, it can be called a main distribution frame and an intermediate distribution frame. I call them facilities, but basically MDFs and IDFs. Now, when we're talking about this, and we're talking about this whole class today, remember, we're talking mostly about networking equipment or the cabling for the network. So again, this is, you know, cabling for the network, switches, patch panels, that type of stuff. We're not necessarily talking about servers. We're just talking about how everything kind of physically connects to each other. So what's going to happen, so we talked about the demarc before. Let's say that you are renting out 4 floors of this office building. So basically, you have your property manager brings up a cable to one of your floors and drops the cable off at the demarc point. So this is where the cabling becomes your responsibility. Now, where they drop off that cable is going to become 2 things. First, it's going to become the demarc between you and the property manager. So this is where everything transfers over to your responsibility. The next thing is that this is going to become the MDF, or what's called the main distribution facility. So the MDF is literally where all the cables come back together to create the overall network. So you know, we're gonna show you in a minute, but basically you have all these spider webs that create the network. This is the one place where they all actually connect back together. So this is the centered part. So you know, if you have lots of weird spidery networks going out, you know, creating voice over IP and surveillance systems and all of that, all of those have to finally, at the end of the day, come back to one central place, and that is the MDF, or the main distribution facility. So normally, when you're dealing with small businesses, this is going to be the same place as your server room. So you know, wherever you put your server, you'll probably have a server rack. You'll have switches, you'll have routers, and you'll have your main patch panel. So that is what is normally the MDF. Basically everything in the entire office or the entire company comes back to that one central point. Now, once you start dealing with larger companies or more complex infrastructure, the MDF and the server room are not necessarily the same thing. Sometimes, for clients that I had, the server room had to be much more secure than the MDF because you know, my clients weren't really worried that people were going to steal a patch panel. They were worried that people were going to try to steal an entire server. So basically they put the server room and they put all the servers in a different place from where the MDF was. But they can be in the same place, they can't be in the same place. The main thing with the MDF is that this is the main central point where all the network connections come back to, telephone connections, everything. This is the main hub for everything that's going to be in your office. Now, you know, when we're talking about cabling, if you know anything about cabling, you know, you've got to physically run a lot of cable. And cable, It is a pain in the butt to run. It's very profitable to run. If you're looking for something to make a lot of money at, running cable is just printing cash. But it's very tedious, it's very time consuming, it's very hard. So now when you're dealing with 4 floors, as you know, when you run a cable, you have to run it basically all the way to the patch panel. So if you have a computer over here, and your MDF's all the way down here, you don't really want to have to run a cable all the way down to that MDF. That's just a lot of running cable. You know, the further you run cable, the more expensive it's going to be, and the more chances that you have that you're going to crimp the cable, you're going to cut the cable, or something's just going to bad happen when you're running that cable. So that's where the concept of IDFs came in, intermediate distribution facilities. So basically, what you have if you have an office with multiple floors is you have one MDF for the entire office, and then every single floor has its own IDF. Now what happens with this is, so you have all these computers here, right? The floor, let's say, has 100 computers. Instead of having to run 100 network drops all the way down to this MDF that may be a really, really long way away. And remember, when you go into network cabling, you've only got 300 meters to deal with. So a normal Cat5 network cable should not be any more than, is it 100 meters. 100 meters, it's only 300 feet. It's not supposed to be that long, or the signal degradation drops off. So with this, instead of running all these cables all the way down to the MDF, you just run these cables over to this IDF. So basically, if you're dealing with a floor, every floor in your building would have its own IDF. All the computers, all the telephones, all the surveillance systems, all of that stuff would run to the IDF for that floor. Each floor then has its own IDF. All the computers, again, run to that IDF. And then what happens is all you do is you then connect these IDFs down to the MDF. So basically, let's say you run 100 cables from all these computers on this floor to the IDF here sitting on the floor. Well, then you can run a single, maybe 2, maybe 3 network cables from the IDF all the way down to the MDF, you know, a few floors below. So instead of running 100 cables down, you're running 3 or 4. This makes life a lot easier, just a lot easier. So when you're dealing with these IDFs, they don't have to be, you know, very nice, beautiful rooms or anything. I mean, basically, you can just take over a little broom closet. You just have all the network cables run in to a patch panel. You put a server, maybe a router if you want it there, and you connect everything together. Now with switches, you know, this is a nice 48-port switch. You know, all the connectors. So this is a 48-port switch. This means 48 computers can connect to the switch. This would be sitting in this IDF up here. Well, one of the things many people don't know is these are called GBIC connectors, or normally they're also called trunk connectors. So basically, all the computers on the floor would connect to the switch, and then this one cable is a fiber optic cable that would then connect all the way down to this MDF. Basically, again, fiber optic's a little more expensive, but you only have to run one fiber optic cable all the way down to the MDF versus 100 normal network cables. Again, fiber optic is better, faster, etc. Than Cat5 cable. So this one little GBIC connection can handle all of the traffic for these 48 ports. So, like I said, it's a pretty simple concept, but most people really don't use this enough. So just understand, you know, you have the demarcation point. The demarc is where authority transfers from one party to the next, you know, from the internet service provider to the building owner, from the building owner to you. When it comes in to you, when it becomes your responsibility, this is then called the MDF, Main Distribution Facility. This is where all the cabling in the entire building or the entire office comes back to. This is a central hub where everything connects to. Again, this can be the same place as the server room, but it doesn't have to be. This is more of a network telephone system type thing. So your server room could be over here on a different side of the building if you wanted it to be more secure. You know, just run a couple cables. But in here, you know, this will be your core routers, your core switches, you know, your core stuff. Then you have the IDFs, Intermediate Distribution Facilities. Every single floor, or every single, like I say, like a physical location for the company would have an IDF. So I dealt with a school at one point that had 6 different buildings, you know, small buildings, you know, 2,000 square foot buildings, but each building, you know, it was separated from all the other buildings. So each building had its own IDF. We then connected that IDF to the main MDF sitting in the main headquarters building, sitting in the middle of the campus, I suppose you could call it. You know, a different place that I dealt with, a swim club, was just this huge, massive building. So it wasn't cost effective to run cables all the way from the server room to every single office space in the entire building. So what we did is we created multiple small, what you could call IDFs in the building. So each one of these little office spaces may only have five people, but all of their cables connected to a little patch panel, and then that patch panel connected to a little switch, and then that switch, we only had to run one cable all the way back to the MDF. This is huge, and like I say, this is very important. As we go into more classes, we'll get more technical, but that's the main thing. The MDF is where everything comes back to. This is where all your core stuff is. IDFs, like I say, it allows you to you know, you don't have to do all of those home runs all the way back to the MDF, because like I say, even if you're making a lot of money doing it, after a while, it's not worth the money. So that's the MDF and the IDFs. Now the final type of segmentation we're going to talk about isn't so much a physical segmentation. This is something you can do logically, but it all just kind of fits into what we've been talking about. And what this is called is the DMZ. It's called the demilitarized zone. And what this does is allows you to open up a portion of your network and your internet connection that basically is more vulnerable to hackers or to outside threats than your core, your more secure systems. So how this comes up a lot of times is, let's say you're running your own web servers. So your web servers, whether we like it or not, many times are going to have to be more vulnerable to hacking than you want your Active Directory servers to be. So let's say you're running a couple of web servers for your company, but on the same internet connection, you also have your internal network. So you have all 100, you know, your client computers and your Active Directory servers and your email servers, etc. Well, those web servers, again, are going to have to be more vulnerable just because they have to be out there on the internet than you want all those client computers and everything to be. That is where you come up with something called a DMZ, a demilitarized zone. So you have the internet cloud out here, and then you have your building, you have your office space. All that happens, all you really that you have to do to create a DMZ or demilitarized zone is basically you use 2 routers and 2 firewalls versus 1, at least for a simple one. So your office space, let's say this has all the very secure computers in it. You don't want these computers to be hacked. Well, then you have these web servers right here, like I say, that have to be out on the internet. You don't want them to be hacked, but if they are hacked, well, that's just how life goes. So what would happen is your internet connection, that will come to a router. You know, so this is your ISP. So you know, Comcast, Verizon, Quest, I don't know, whatever you guys have. This could be a T1 line. This could be, again, cable internet line. This could be DSL line. Doesn't matter. It's just whatever internet connection you have. So what's going to happen is that's going to come in to this router and to this firewall configuration. Now, since you have your web servers here, this firewall and router configuration is going to have to be as open as you need it to be. So things like port 80 are going to have to be open. You know, FTP ports may have to be open. A lot of different ports may have to be open. So basically what happens is under the router is you have a switch. And these computers or these servers get hooked to that switch. So these are now in the DMZ. Now there'll be another connection that goes from the switch to your more secure router. So basically you have one router here. This is very open, this is very insecure because you have to allow your web servers to be able to get out to the internet. Well, then you have one connection from the switch that goes to your super secure router. So this router, let's say all the ports are completely locked down. You can only do email or web surfing. That's all you can do. And then on the other side of this is your entire internal network. So basically all the DMZ does is it gives you a space on your network that is less secure. So you can have a super secure section of your network and a less secure section of your network. Now here I was talking about web servers. I did this for one of my clients who unfortunately even a year or two ago still had to have a T1 connection just because where they were located. They were located in Baltimore City, but just how everything works out, they couldn't get Comcast, they couldn't get DSL, satellite sucks. Yeah. So they still had to have a T1 line that cost $450 a month. Again, only 1 or 2 years ago. So they didn't want to have to, you know, they wanted to be able to give their clients, the people that came to the swim club, internet access without having to pay another $450 a month to give it to them. So what we did is we created DMZ for the members of the club, and basically, so we had the internet, you know, coming down to their router, their ADTRAN. They had a switch off that router. On one connection of the switch, we put a little wireless access point. So this allowed all of the members of that swim club to be able to get onto the internet and surf and do all the stupid crap that they wanted to do. But then one connection goes from the switch to the super secure router, and all of their mission critical stuff, you know, their client computers, their servers and everything were behind this super secure router, you could say. So this is how it works out in the real world, and this is actually probably how you're going to set it up if you have clients that need something like a DMZ. Is basically you have the internet connection comes to your router. You plug that in, like I say, to a wireless access point, so everybody who wants to get on the internet can. But then behind that, you put another router. You lock that router down, so you know the firewall is locked down, ports are locked down, etc. And then you put all the most secure stuff behind that. That's how the DMZ works. You can actually get really complicated with this. You can do multi-layers of DMZs, but this is the basic concept. So all you really have to understand with the DMZ is if you have a section of your network that has to be less secure than the rest of your network, again, you can create this DMZ. Basically, you use 2 routers. The first router is pretty open, so anybody who connects using that router can basically do whatever they want, and they can also probably get hacked. Then behind that first router is a second router. This router is much more secure. This is where you lock down all the ports. You just make it, you know, totally secure, so it protects everything that's sitting behind that second router. That's really all a DMZ is. So that's really all there is to the physical segmentation of networks. Again, I want to talk to you about it today because I've noticed in a lot of college classes, a lot of these certification classes, they're not teaching this kind of stuff anymore. And like I say, this is very important. You know, understanding how you're going to lay out your network and who's responsible for what is huge. You know, we talked about the Demarc, or the demarcs, the Demarc point, the demarcation points. Basically, this is where authority transfers from one party to the next. So like I say, the telephone company's Demarc is normally sitting right on your building. If there's a good signal at that Demarc, it means it's whatever problem you're having is your problem. If there's not a good signal at the Demarc, it means whatever problem you're having is a telephone system's, it's a telephone company's problem. It's very simple. It's very easy. Again, if you're renting office space in a building, at that Demarc point for the telephone company, it then goes from the telephone company's responsibility to the property manager's responsibility. Then however long that cable is, the property manager will then drop a Demarc in your office space. So basically, it goes from the property manager's authority to your authority. Again, you know, where this becomes massive problems is, like I say, with business owners or technicians. If you don't understand how this Demarc thing works, I've seen, you know, the local telephone company, I've seen people scream themselves blue, screaming at Verizon about problems with their network, where it wasn't Verizon's problem. You know, Verizon The signal works all the way up to the Demarc. It is not Verizon's problem. The next thing too is, like I say, is if you're renting a space in a building and you don't realize that the property manager is responsible for the cable that runs from the telephone company's Demarc to your office space, again, you may be screaming at the telephone company when it's not the telephone company's problem. And again, I've dealt with this so many times in the real world. Property managers will sit there and twiddle their thumbs and whistle. And a lot of times they don't want to deal with problems. Like I say, there's cabling problems that are their responsibility. Again, I have seen this in the real world. I have seen flooding in basements that get the cabling wet, and then the cabling in the building just becomes corroded, so you don't get the signals you're supposed to be getting. I've seen rats eat through these main trunk cables that are supposed to be running through the building. It can really be a huge problem. And like I say, is if you think it's a telephone system's or it's a telephone company's problem, you're going to be screaming at the telephone company for 4 weeks before you find out that no, it's not the telephone company's problem, and then it's really property manager's problem. Now you have to get the property manager to do it, and now it'll take you 2 months to get something fixed. It can just be a real horrible pain in the butt. So the Demarc, like I say, transfers from one party to the next. In our other networking classes, I'll show you how you test these Demarc points. Again, this is more like the theory, the overview. Now, the next thing that we talked about were MDFs and IDFs, main distribution facilities and intermediate distribution facilities. They may also be called main distribution frames or intermediate distribution frames. Basically, where that Demarc point is, where all the cabling comes in, that will also normally be your MDF. So all the cabling, all the telephone system, your computer system, all the cabling, that will be the core of where all the stuff comes in. So no matter how all the wiring spiders out, if you have a really big building, all that wiring at the end of the day comes down to this core, this MDF. So the MDF, again, this is where you have your core routers, your core switches, etc. Everything connects here. Now, normally, if you're dealing with a small office, 20 to 100 people, the MDF and the server room will almost always be the same thing. If you're dealing with a larger office, or if you're dealing with special security concerns, etc., the MDF and the server room may be two entirely different things. So, like I say, with one of the clients I had, the server room was in a super secure part of the building. The MDF was not. They weren't worried about anybody stealing their patch panel. So the main distribution facilities where everything comes in and connects together. You then have the IDFs, intermediate distribution facilities. This is, again, if you're dealing with a client that has multiple floors, they're renting out an office space, so they have multiple floors, or they have multiple buildings on the same campus. Basically, on that floor or in that building, you run all the cables back to a central location. That's the IDF. You can then run one cable or two cables from that IDF all the way to the MDF, wherever it is. Again, a lot of times you'll use fiber optic cables to do that. But it's a lot easier to run one or two fiber optic cables versus literally 100 network cables. so that's what the IDFs are for. Everything goes back to an IDF. The IDF grabs that, and then it takes one or two cables down to the MDF. Again, how that works is when you're dealing with a switch, again, you have 48 ports. These are the normal networking ports. Then you have what are called the GBIC or the trunk ports. These trunk ports can handle much more data than any individual port on here can. So basically everything that's happening here gets shoved down this one little GBIC line all the way back to the core system. Yeah, pretty simple. Then finally, we talked about DMZs, demilitarized zones. The main thing that you have to understand with DMZs is you don't have to use these a whole lot. With all the clients that I had, I probably set up, I don't know, 5, 6 DMZs. It's not a huge thing. But if you want to share out, like I say, your internet connection between systems that have to be very secure and systems that have to be less secure, then you want to use a DMZ. Again, you have the internet connection that comes into a router. To make the DMZ work, that first router is pretty open, so people can get in and out. So basically your servers, whether they're web servers or whether you have client computers that need to access the internet, they can get out very easily, but they can also get hacked. It's just the trade-off that you have to make. Well, Behind that one router, so you have the one router that's pretty open, connected to whatever systems that are part of that DMZ. Behind that router will be a second router. That router, when firewall, will be set up to be very secure so that things cannot get hacked very easily. And then underneath that router will be, like I say, your Active Directory servers, your email servers, your client computers, etc. Everything that is supposed to be really secure will be underneath that second router. That's really all there is to it. Again, as I say, like I say, these are overall concepts. Just when you go to your client site, or when you go and you're building out offices, just think about this a little bit. Like I say, you don't have to do home runs. You don't have to do runs from every single out port all the way to the server room all the time. You can go to IDFs. This really makes your life easy. Just keep these concepts in mind. Like I say, it'll make your life so much easier. So, as you know, I'm Eli the Computer Guy, over here for Everyman IT. This was physical network segmentation. There's a lot of topics we went in. We talked about slightly. We will go into in more depth in other classes. This is just an overview of how some of this stuff works. As always, it was really good to see you at the class. I look forward to seeing you at the next class.